Hello everyone, and welcome. Today, we're going to tackle a topic that sounds a bit serious, right? Increasing and decreasing functions. But trust me, by the end of this, you'll see how simple and logical it really is. Let's make it super easy.
Okay, let's start with something you all know. You see a new filter on Instagram, right? Ever wondered what makes it go viral? Like, everyone is using it? Versus the ones that just fade away in a week. How can we actually predict that?
Well, the popularity of any trend, think of a filter, a meme, anything, it usually follows a pattern, almost like a curve. First, it just explodes. Its popularity shoots up super fast. That's the increasing part. Then it hits a peak and you see it everywhere. And after that, it slowly starts to die down. And that's the decreasing part. This whole journey of going up and then coming down, that's exactly what we're talking about with functions.
Okay, so let's put this into proper math terms, but I'll keep it simple, I promise. We say a function is increasing if, as you move from left to right along the graph, the line is going up. Simple as that. It's just like that Instagram filter going viral. As time passes, that's our x-axis, the number of people using it, that's our y value, or f of x, just keeps going up and up.
And I'm sure you can guess the next part. A function is decreasing if, as you move to the right, the graph is heading downwards. This is that fading away phase of our trend. Time is still moving forward, but now the filter's getting old, and the number of users, our f of x, is dropping.
Okay, but hold on. Are we going to draw a graph every single time to figure this out? No way! That would take forever, especially for some really complicated functions. So, the big question is, how can we know if a function is increasing or decreasing just by looking at its equation? Well, this is where calculus comes in with a super powerful tool.
And this secret weapon is the derivative, f prime of x. Yep, that same derivative we've been calculating. Now we're finally going to unleash its true power and see what it can really do.
Okay, listen closely now, because this is the most important idea of the entire topic. If you remember just one thing, make it this. The sign of the derivative, that is, whether it's positive or negative, tells you the direction of the function. It's literally like a GPS for your graph, telling you if it's going uphill or downhill. So here's the rule. It's super straightforward. If the derivative, f prime of x, is positive, greater than 0, that means the function is increasing. Think of it like your follower count growing. It's a positive change. And on the flip side, if f prime of x is negative, less than 0, that means the function is decreasing, like your screen time hopefully going down after exams, and negative change. Simple, right?
But what about the third option? What if the derivative isn't positive or negative, but it's exactly 0? Well, in that case, the function is constant. It's not going up, it's not going down, it's just flat. It's like you've paused a YouTube video. The picture isn't changing at all.
Okay, enough theory. Theory is good, but let's see how this works in practice. I'm going to give you a simple 3-step game plan. If you follow these 3 steps, you can solve any problem on this topic. I guarantee it.
So here's the game plan. Step 1, find the derivative, f prime of x. That's always the first thing you do. Step 2, find something called the critical points. These are the potential turning points of our graph. And how do we find them? We just set the derivative, f prime of x, equal to 0 and solve for x. And finally, step 3. We test the sign of our derivative in the different zones or intervals that our critical points have created. That's what tells us if the function is increasing or decreasing in each part.
All right, let's stop talking and start doing. We're going to take our 3-step game plan and apply it to a real problem, straight from your NCERT textbook. This is where you'll see how beautifully it all connects.
Okay, here's the function we're going to work with. It's f of x equals 2x cubed minus 3x squared minus 36x plus 7. Our mission is to find out exactly where this function is going up and where it's coming down.
All right, let's start with step 1 of our game plan. Find the derivative. We just use the power rule here. So the derivative of 2x cubed becomes 6x squared. The derivative of minus 3x squared becomes minus 6x. The derivative of minus 36x is just minus 36. And of course, the constant 7 goes to 0. So our derivative, f prime of x, is 6x squared minus 6x minus 36. Step 1, done. Easy peasy.
Now for step 2, find the critical points. To do this, we take our derivative and set it equal to 0. So we have 6x squared minus 6x minus 36 equals 0. Now, to make our lives easier, notice that everything here is divisible by 6. So let's divide the whole thing by 6. That gives us x squared minus x minus 6 equals 0. A simple quadratic. We just need to factorize it. We need two numbers that multiply to -6 and add up to -1. And what are those? Yep, -3 and +2. So this becomes x minus 3 times x plus 2 equals 0.
And from here, the solutions are obvious, right? Our two critical points are x equals 3 and x equals -2. Now, these aren't just random numbers. These are super important. They are the only places where our function can possibly switch from increasing to decreasing or from decreasing to increasing. They're the turning points.
So what do we do with these points? Imagine a number line stretching out forever in both directions. Now, let's place our two critical points, -2 and 3, on this line. See what they do? They've split the entire number line into 3 separate zones, or intervals. The first zone is everything to the left of -2. That's -infinity to -2. The second is the zone between them, -2 to 3. And the third is everything to the right of 3, so 3 to infinity.
Okay, this is the final step, step 3. We need to check the sign of our derivative in each of these 3 zones. So let's pick a test value from each one. For the first interval, let's pick something easy, like x equals -3. If you plug that into our derivative, you'll get a positive number. And what does positive mean? Increasing. Now for the middle zone, between -2 and 3, the easiest number to pick is 0. Plug that in, and you'll get a negative number. And negative means decreasing. Finally, in the last zone, let's pick x equals 4. Plug that in, and you get a positive number again, which means the function is back to increasing.
And just like that, we're done. We've cracked it. We can now say with full confidence what this function is doing. It's increasing on 2 separate intervals, from -infinity all the way to -2, and from 3 all the way to infinity. And it is decreasing in that one interval in the middle, from -2 to 3. See? The game plan works.
Okay, we covered quite a bit there, but you followed along perfectly. Before we finish, let's do a super quick recap to make sure these ideas really stick in your head.
So what are the key takeaways? Number 1, the secret is all in the sign of the derivative. That tells you everything. Number 2, a positive derivative means the function is increasing. It's going up. Number 3, a negative derivative means the function is decreasing. It's going down. And number 4, our foolproof 3-step game plan. Differentiate, find critical points, and test the intervals. That's your recipe for success every single time.
So from now on, whenever you see a function and you're not sure what it's doing, just remember, to know where the function is going, you just need to ask its derivative for directions. Thanks for joining me today.